Good morning, students. In the previous session, I had worked out some problems in which we made use of the properties. Now, it's a continuation of the previous session. Same type of problems where I am going to prove certain results will be worked out now. Now, the first problem in this session is prove that 3 times sin inverse x, 3 times sin inverse x is equal to sin inverse of 3x minus 4x cube. 3 times sin inverse x equal to sin inverse of 3x minus 4x cube. X belonging to the closed interval. X belonging to the closed interval minus 1 by 2 comma plus 1 by 2. So, when x belongs to that interval, when x takes the value between minus half and plus half, we are going to prove this result. Now, here I told you in the previous sessions, usually we start with the left hand side, arrive at the right hand side. In this problem, it is easier to start with the right hand side to go to the left hand side. Look at the function inside the square bracket, 3x minus 4x cube. Outside we are having sin inverse. That gives us an idea, it has to be written in terms of sin of something, so that I can make use of sin inverse of sin sin inverse of sin x can be written as x. So what I do is, I will make an assumption here, start with the right hand side. Here let x be equal to sin theta. Then theta can be written as sin inverse of x. So first make an assumption. Now start with the right hand side. What do you have on the right hand side? Sin inverse. X has to be replaced by this quantity. That is 3 into sin theta minus 4 times sin cube theta. Look at the expression inside the bracket. 3 sin theta minus 4 sin cube theta. What is that actually? Again, it is another multiple angle. Sin 3 theta is equal to 3 sin theta minus 4 times sin cube theta. We have studied this in first year PUC about the multiple angle formulae. That means that this can be written as sin inverse of sin of 3 theta. Okay, sin inverse of sin of 3 theta. So, that is sin inverse of sin x would be equal to x. I can write it as 3 theta. But what is theta? Theta is sin inverse x. Therefore, it is 3 times sin inverse x. In this case, it is the left hand side. Even this is for a 2 mark question you can expect. So, when you make an assumption like this and write this, you get 1 mark for that one. Then writing the formula, the appropriate formula, and using this information, writing 3 theta, and theta has to be replaced by the original assumption. Using that assumption, we get the remaining mark for this one. It is usually given for a 2 mark question here. So, 3 sin inverse x can be expressed as sin inverse of 3x minus 4x cube. Now, along the same lines, we can prove another problem here. Instead of sin inverse, I'll give you cos inverse. The procedure is same. And it is also expected for a 2 mark question only. That is 3 times cos inverse x. 3 times cos inverse x would be equal to cos inverse of 4x cube minus 3x. Cos inverse of 4x cube minus 3x. Here the condition is x belongs to the closed interval half comma 1. Okay. So, this is the closed interval to which the variable x belongs to. Under this condition, we can show that 3 cos inverse x equal to cos inverse of 4x cube minus 3x. Here also, look at this one. 4x cube minus 3x, outside we are having cos inverse. That means that try to write this function in terms of cos of something. For that, what can be the substitution? X can be taken as cos theta. Therefore, how do you write theta? Theta would be equal to cos inverse of x. Now, let me start with the right hand side. So, cos inverse you write as it is 4 into What is x cube here? X cube means it becomes cos cube theta and then minus 3 times cos theta. Again, in first PUC, we have learned that cos of 3 theta, the multiple angle formula, cos of 3 theta is equal to 4 cos cube theta minus 3 cos theta. So, I am using that result here. So, the function inside the bracket can be replaced by cos of 3 theta. Now, using the information, cos inverse of cos theta is equal to theta. Instead of theta, we are having only 3 theta. But what is the theta? Theta should be written as 3 times cos inverse x, which is the left hand side. So, even this can be expected for a 2-mark question. The difference is, in the earlier one, we had made use of the sin 3 theta formula. We are making use of the cos 3 theta formula. Now, let us move on to another problem where we will be using the tan inverse function. Some result connected with tan theta we are using. So, let me take the next problem. Tan inverse of x, you have to prove this result. All these results we are proving. Tan inverse x plus tan inverse of 2x divided by 1 minus x square. Now, this is the left hand side. Tan inverse x plus tan inverse of 2x divided by 1 minus x square should be shown. This is equal to tan inverse of 3x minus x cube divided by 1 minus 3x square. This is the right hand side. Again, it is in terms of tan inverse only. Tan inverse of 3x minus x cube divided by 1 minus 3x square. Here the condition is mod x, modulus of x should be less than 1 by square root of 3. So, under this condition, we are proving the result. Now, on the left hand side, there are 2 terms here. Look at the right hand side, there is only 1 term. So, what we do is here, let us make an assumption for the right hand side. Here again, look at the right hand side, tan inverse we are having. Try to express this in terms of tan of something if possible by making a proper substitution. Then tan inverse of tan theta could be written as theta. So, that is a procedure for the right hand side. Let us come to the left hand side. Tan inverse x we can write, and look at this one. We had 3 results in the last property. The first one being 2 tan inverse x equal to tan inverse of 2x divided by 1 minus x square. Now, look at the second term here, it is just like the right hand side. So, instead of this one, I can write it as 2 tan inverse x. So, using the property 5 here, first let me write the left hand side. Left hand side could be written as tan inverse of x. Write it as it is. This can be replaced by 2 tan inverse x. 2 tan inverse x using the property. So, 1 tan inverse x plus 2 tan inverse x, that would be equal to 3 tan inverse x. Okay. So, we have shown the left hand side equal to 3 tan inverse x. Now, for the right hand side part, I make an assumption, that is, let x be equal to tan theta. Then, what would be theta equal to? It is tan inverse of x. Now, start the right hand side. Right hand side is right tan inverse as it is. Now, 3x, that is 3 tan theta, x cube, that is tan cube theta, divided by 1 minus 3 into tan square theta. Look at the function inside the bracket. It is nothing but the multiple angle formula tan of 3 theta. So, one problem I used sin 3 theta, other one I used cos 3 theta. I am using the tan of 3 theta. We know the formula. Tan 3 theta is equal to 3 tan theta minus tan cube theta divided by 1 minus 3 times tan square theta. These are all standard results. Wherever you want, you can use that one. So, I can write this as tan inverse of tan of 3 theta. So what is that one? Using that information again, I can write it as 3 theta. Now what is theta? According to our assumption, theta is tan inverse x. Now look at the left hand side. I got tan inverse plus 2 tan inverse, 3 tan inverse. And the right hand side also, I got the same answer, 3 tan inverse. That means both the left hand side as well as the right hand side have simplified and shown that both of them are equal to each other. Therefore, I can write the left hand side equal to right hand side. So this is how we have to solve these problems. Now let me move on to another problem. See, we cannot apply the same procedure, same assumption for all the problems here. Now we have to look at the function that is given, the terms that have been given in a particular problem. Depending upon that one, we can make the proper assumption. So when sine inverse was there, I took it x equal to sine theta or x equal to cos theta or x equal to tan theta, depending upon the terms that have been given in a particular problem. We can adopt the same assumption for all the problems. It is not possible. Now let us move on to the next problem. You have to prove that tan inverse of root x equal to half of cos inverse of 1 minus x over 1 plus x, and the x belonging to the closed interval 0, 1. Now in almost all the problems where I proved certain result, either they involved sine inverse, cos inverse, only one function was involved. Here look at the left hand side, we are having tan inverse. Look at the right hand side, we are having cos inverse. So we have to look at the terms that have been given and carefully you have to make the assumption. Left hand side, I am having radical function is there, some root of some function is given. First let me try to eliminate that one. To eliminate now, I have to make an assumption for x in such a way that the root sign can be eliminated. So let me make the assumption, let the x be equal to tan square theta. Let x be equal to tan square theta. That implies that root x equal to tan theta. Root x equal to tan theta. Therefore, that implies that theta is equal to tan inverse of root x. That means that the left hand side tan inverse of root x will be now equal to theta. Now let me make the same assumption to the right hand side also. So let me start with the right hand side. That is half of cos inverse of what I have to write for x here, it is tan square theta 1 minus tan square theta divided by 1 plus tan square theta. Now again we go to first year PUC portion. In first year PUC we have learnt about the multiple angle cos 2 theta, sin 2 theta, etc. Now sin of 2 theta and cos of 2 theta, both of them can be expressed in terms of tan theta. That is, we know this result already. Cos of 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. Now I am using that property, and how do you write this one? It is half of cos inverse of the function inside the bracket could be replaced by cos of 2 theta. So cos inverse of 2 theta, how could you write that one? It is half of 2 theta. Okay, because it's a trigonometric function, its own inverse I am operating, it becomes half of 2 theta. 2 and half they get cancelled, it is theta. But what is theta? Theta is nothing but tan inverse of root x. But what is tan inverse of root x? It is nothing but the left hand side. So in this problem also, I have made an assumption here. I have started with the right hand side, applying the compound multiple angle formula, cos inverse of cos 2 theta. After cancellation, we arrive at theta. Theta is nothing but the left hand side, that is tan inverse of root x. Now this is how, see in all the earlier 3-4 problems, no, whenever we had a function, both the sides of the function are the result, I can say, they involve the same type of function, either sine or cos or tan. In this one is tan inverse, the other is cos inverse. So looking at the terms, we have to carefully make an assumption. Now let us move on to the next problem. That is, you have to show that tan inverse of the expression is a little bit big here. It is 1 plus x minus root of 1 minus x divided by root 1 plus x plus root of 1 minus x. Tan inverse of root 1 plus x minus root 1 minus x over root of 1 plus x plus root 1 minus x. We have to show that it is equal to pi by 4 minus half of cos inverse of x. Pi by 4 minus half of cos inverse of x. Here it is the value of x has been specified minus 1 by root 2 less than or equal to x less than or equal to 1. So under these values, x lying between minus 1 by root of 2 and plus 1, we have to prove the result here. Now we can start with the left hand side. You can show that it is equal to the right hand side. See, look here, tan inverse I am having outside. Okay, so that that gives us an idea. This quantity somehow should be written in terms of tan of something. For that, no, you have to make an assumption here. That again, look at the right hand side. Cos function is involved. So let me make the assumption. Let x be equal to cos of 2 theta. Need not be cos of 2 theta. You can take cos of theta also. When you take cos of 2 theta, you will be getting angle theta in the coming steps. When you take theta, it will be half angle, theta by 2, like that. So usually we avoid that half value, so better take it as cos of 2 theta. This is a little bit lengthy problem, so you can expect it for a 3-mark question. Let x be equal to cos of 2 theta. What does it imply? It is 2 theta is equal to cos inverse x. Therefore, theta would be half of cos inverse of x. As soon as you make an assumption, write the whatever you have made the assumption, write that in terms of the given variable, because finally you have to replace it by the given variable only. So this habit you better develop. As soon as you make assumption, write that also. Now let us start with the left hand side. On the left hand side, replace x by this function. What is that we have taken for x here? 1 plus cos 2 theta minus root of 1 minus cos 2 theta. Denominator root of 1 plus cos 2 theta plus root of 1 minus cos 2 theta. Only signs are different, that's all. Now again we are using the multiple angle formula, that is sin 2 theta, cos 2 theta, etc. Now we know that 1 plus cos of 2 theta, 1 plus cos of 2 theta is equal to 2 cos square theta. If 2 theta is there, take half of that one. Similarly, 1 minus cos 2 theta equal to 2 sin square theta. All these things you have already learned. I am making use of the standard result here. So this can be written as root of 2 cos square theta minus root of 2 sin square theta divided by root of 2 times cos square theta plus root of 2 times sin square theta. Now look here. All of them are having, we are having square terms here. So that root gets cancelled, but root 2 you have to write as it is. Root 2 cos theta minus root 2 sin theta divided by root 2 cos theta plus root 2 sin theta. Now root 2, of course, you can take out as a common factor. Root 2 gets cancelled from the numerator as well as in the denominator. Now what is remaining after dividing by root of 2? We are left with cos theta minus sin theta divided by cos theta plus sin theta. Actually, we had done a problem in the previous session which resembled almost the same type of terms we had. Now here, even now, we are having tan inverse outside, and inside the bracket it is again with this in terms of sine and cosine. Directly we don't have any tan function there. So how do you convert that one? You know that tan theta is equal to sin theta by cos theta. Therefore, inside the bracket you divide the numerator and denominator by cos theta. Inside the bracket you do this one. So how do you write this one? The left hand side is tan inverse of cos theta by cos theta is 1. Sin theta by cos theta is tan theta divided by cos theta by cos theta is 1. Sin theta by cos theta, it is again tan theta. So tan inverse of 1 minus tan theta over 1 plus tan theta. Now again I rewrite so that it comes to the standard form. 1 minus tan theta, right? This tan theta, I can write it as 1 into tan theta. Now again the fourth result, what does it say? Tan inverse of x minus tan inverse of y is tan inverse of x minus y over 1 plus x into y. In the place of x, 1 is there. In the place of y, I am having tan theta. So how do you rewrite this one? I can write it as tan inverse of x, that is tan inverse of 1 minus tan inverse of y. What is y here? It is tan theta. Now tan inverse of 1, it is pi by 4. You know that already. Tan inverse of tan theta is theta. But theta has been calculated in the beginning itself. It is half of cos inverse of x. Hence we get the right hand side. Now this is quite a, I can say it is a standard problem where it can be expected for a 3-mark question again. It's a little bit lengthy. So we start from the left hand side. We make a proper substitution. We make use of the multiple angle formula, then dividing, making this manipulation here, it comes to the standard form where again I am making use of a property, and using that result finally we arrive at the right hand side. So it is again I am telling you, it's a standard problem. You can expect such problems for a 3-mark question. Now another problem of the same type, that is instead of tan inverse, I am having cot inverse. That is, you have to prove that cot inverse of the function inside the bracket is root of 1 plus sin x plus root of 1 minus sin x divided by root of, again same thing, 1 minus sin x, 1 plus sin x minus root of 1 minus sin x. Now this is the problem we are having. Now we have to prove that this is, see left hand side we have got quite a big expression. The right hand side is a simple term, that is simply x by 2, x belonging to the open interval 0, pi by 4. Now this is the interval to which it belongs. Now we have to start with the left hand side and arrive at the right hand side. Now look at the function. In the previous problem we had here root of 1 plus x, 1 minus x, etc. X was given. So you could make in trigonometric substitution for x, taking to be cos of 2 theta. Whereas here it is already given in terms of the trigonometric function itself. So you cannot make any substitution here. Of course, you can make use of the half angle formula here, but the easier method is you simplify the expression which is given inside the bracket. That is, let me consider that expression, then I will come to the left hand side part. That is, consider root of 1 plus sin x plus root of 1 minus sin x divided by root of 1 plus sin x minus root of 1 minus sin x. See, to eliminate this radical sign, let me multiply and divide by the sort of conjugate of this one. That is, multiply and divide by this function. Root of 1 plus sin x plus root of 1 minus sin x. Now look at the numerator here. It is a plus b into a plus b. So we use our high school algebraic formula. A plus b into a plus b is a plus b the whole square. Root of 1 minus sin x the whole square. And look at the denominator. It is a minus b into a plus b. Another algebraic formula, a minus b into a plus b is a square minus b square. What is a here? A means it is root of 1 plus sin x the whole square. B means root of 1 minus sin x the whole square. So I am making use of the algebraic formula of high school classes. So a minus b, a plus b into a minus b is a square minus b square. Now numerator is a plus b the whole square. What is the expansion of a plus b whole square? A square plus b square plus 2 into a into b. Let me use that one. A square means root of 1 plus sin x. When you take root and square, that root and square they get cancelled, it becomes 1 plus sin x. Again, root of 1 minus x the whole square. Taking root and squaring, we get the original function, that is 1 minus sin x plus 2 into a into b. Here the root remains as it is. Afterwards we will simplify that one. Okay. Now denominator is, this is again taking root and squaring, it is 1 plus sin x. Now write inside the bracket, because we are having a minus sign, 1 minus sin x. Now let us, if possible, let me do cancellation. Plus sin x and minus sin x, they get cancelled. 1 plus 1, that would be equal to 2. Now look at the other one. It is under the radical sign only, 1 plus sin x into 1 minus sin x. Again using the algebraic formula, a plus b into a minus b, that is 2 into root of a square minus b square, 1 minus sin square x. Denominator, let me remove the brackets. 1 plus sin x minus 1 minus of minus plus sin x. So here plus 1 and minus 1, they get cancelled. Now let us add the remaining terms. And 2 into, look here, 1 minus sin square, as you know, is cos square x. And root of cos square x is cos x. So we get here 2 plus 2 cos x, and denominator 1 sin x plus another sin x, it is 2 sin x. So what we have got here? 2 plus 2 cos x over 2 sin x. Now let us come to the left hand side part here. That is cot inverse of. Now 2 can be taken as a common factor. So it becomes 1 plus cos x numerator, and denominator 1 minus cos x. So I have considered only the function inside the bracket. Using the rationalization method and using the identities and using the algebraic formula, I have arrived at a simple result here. It is 1 plus cos x divided by sin x. Here 2 gets cancelled. Now again here I make use of the half angle formula. It is cot inverse of 1 plus cos x is 2 cos square x by 2. Those results of first year PUC, they are very important. Whenever we discuss about trigonometry, we will be using some result or the other. Sin x, write in terms of half angle. 2 sin x by 2 into cos x by 2. See how much a simple expression we have got now. 2 and 2 you cancel. 1 cos x by 2 you cancel with 1 in the numerator. So what is remaining now? It is cot inverse of numerator, another cos x by 2. Denominator, we are having sin x by 2. So we are going to the basic definition. You know that cot theta is equal to cos theta by sin theta. Hence I can write it as cot inverse of cot of x by 2. So that information, a trigonometry function, its own inverse here, that is equal to x by 2, which is nothing but the right hand side. Okay, so this is the next. In the previous one, this one, both the problems are of the same type. The difference is, in the previous problem we had x there, so we had to make a substitution for that one, whereas in this problem it was already given in terms of the trigonometry function, so there was no need to make any assumption, but I have to use the other method, rationalization, using the identity, the algebraic formula. We have to arrive at the result. Now one more problem I want to solve, and then I will be completing this session. In the next problem, though I am proving the left hand side equal to right hand side, before proving I want to make some adjustment, readjustment of the terms, then I will try to prove the result. The problem is like this: prove that 9 pi by 8 minus 9 by 4 sin inverse of 1 by 3, that should be equal to 9 by 4 sin inverse of 2 into root 2 divided by 3. So this is the problem that we have to prove. Our usual practice, as you know, is we start with the left hand side, arrive at the right hand side. But here, before doing that one, before following that procedure, let me simplify or let me rewrite the function, because you observe here 9 pi by 8, it's a constant we are having. This is involving sin inverse, that is also involving sin inverse. So let me take both of them on the same side, that is 9 pi by 8 can be written as 9 by 4 into sin inverse of 1 by 3 plus 9 by 4 into sin inverse of 2 root 2 divided by 3. I am simplifying the function itself so that afterwards proving becomes a little bit easy. Now what is the common factor here? 9 by 4, 9 by 4 and 9 by 4. So I can divide throughout by 9 by 4, both the left hand side as well as the right hand side. So 9 is cancelled, 1 4 is cancelled. Ultimately what is remaining on the right hand side? Pi by 2. And on the right hand side it is sin inverse of 1 by 3 plus sin inverse of 2 into root 2 divided by 3. So here let me take the right hand side, show that it is equal to the left hand side. See, look at the left hand side, we are having pi by 2. See, that gives us an idea, a hint, that in the third set of property, what we had learned in the earlier sessions, it is sin inverse x plus cos inverse x is equal to pi by 2. Not only this one, two more results you have studied. Secant inverse x plus cosecant inverse x equal to pi by 2. Tan inverse x plus cot inverse x is also equal to pi by 2. I am considering only this one because it is involving sin inverse function. See, that shows that the pi by 2 is the answer we need here. One is sin inverse, another is also sin inverse. If you could express either this or that in terms of cos inverse having the same value, then directly that the rule or the property could be utilized. And observe here 1 by 3 and this one, both of them are not standard values, but they are valid because they lie between -1 and +1. Now let me, here again we don't have any restriction, either you can make an assumption for this or you can make an assumption for this one. So what I do is, to start with the right hand side, to arrive at the left hand side here, let me make an assumption. Let sin inverse of 1 by 3 be equal to theta. That is, sin theta would be equal to 1 by 3. Let me frame a triangle here, right angle triangle, mark it as angle theta. How do you define sin theta? Opposite over the hypotenuse. So two sides are given using the Pythagoras theorem. This is square root of 3 square minus 1 square. 3 square is 9 minus 1 square is 1. Root of 9 minus 1, 8. Root 8 can be expressed as 2 root 2. Now here let me consider cos theta. What is cos theta? Adjacent over the hypotenuse, that is 2 root 2 divided by 3. Now here theta can be written as cos inverse of 2 root 2 divided by 3, isn't it? So I started with sin inverse 1 by 3 being equal to theta. Using the definition, sin theta has been written as 1 by 3. And using the definition of sin theta, I have marked the sides in the right angle triangle. I could calculate the remaining side. I have taken the ratio cos theta, 2 root 2 divided by 3. Therefore, theta could be written as cos inverse of 2 root 2 divided by 3. But what was theta earlier equal to? It was sin inverse of 1 by 3. So let me start with the right hand side. Sin inverse 1 by 3. First let me write it as it is, then let me replace it by the newly calculated quantity. Sin inverse of 1 by 3 plus sin inverse of 2 root 2 by 3. What is sin inverse of 1 by 3 now? Can be written as cos inverse of 2 into root 2 divided by 3 plus sin inverse of 2 into root 2 divided by 3. So having the same value, I have written in terms of cos inverse. Now let me come to this result. What does it say? Sin inverse x plus cos inverse x equal to pi by 2. What was the condition? X should be same in both the places. Here you observe cos inverse of 2 root 2 by 3. Same thing, sin inverse of 2 root 2 by 3. Therefore, I can write it as pi by 2, which is the left hand side. And when you write this one, always you quote it, since we know that sin inverse x plus cos inverse x equal to pi by 2. It is a property we are quoting. Hence we get the result here. Now there is no rule that you have to make it as theta. You can take this also to be equal to theta. In that case it becomes 2 root 2 by 3. Here 2 root 2 and 3. This becomes 1 in that case. Then it will be cos inverse of 1 by 3. Either this or that. Both are correct. This or that can be taken as theta. The other would be written in terms of cos inverse. If you take this as theta, this would be written in terms of cos inverse. Or if you take this, no, you can write it as cos inverse of 1 by 3. Hence, the same procedure, same property, I am making use of this one. Hence, I get the right hand side, left hand side, which is equal to pi by 2. Though in the given problem, we had too many terms. No, look at always the function. If it could be rewritten in a simple way, so that we can easily prove the required result. Okay. So, these are the problems. In the next session, I am making use of again the properties only and want to work out some more problems. Here one is proving some result, one type of problem, another one to express in the simplest form, that is another type of problem, and the last one is we will be solving some equation where we make use of the properties of the inverse trigonometric function. Thank you.